Okay, let's get started. So let's just start out with the word temperature. And it's basically how hot or cold something is. I want to point out something that I will use in physics, and it's this 3 lines. It looks kind of like an equal sign, except there's an extra line, and it means is defined as. So just be aware for that in the future. So the question is, how do we measure temperature? What tool do we use? We use a thermometer, right? And there are 3 different scales you've probably heard of. Actually, you've probably heard of 2. You might have heard of the 3rd. So the first one is when you think of, when I ask what's the temperature outside, you generally answer me in Fahrenheit, right? And if you go to England, they'll answer you in Celsius, right? So Celsius is sometimes also called centigrade. And finally, the last scale that we use for temperature is called Kelvin. Okay, so the question is, where do we actually use these, right? So Fahrenheit, right, that's what we use. So the US and, I don't know, maybe Cuba. Very, very, very few places actually use Fahrenheit. Celsius is, everywhere else. And Kelvin is what we use in science. Yay. So Kelvin is what's called an SI unit for temperature. SI stands for, if I had a good French accent, I could say this nicely, but like Système International, so international system of units. But Kelvin is what people use in science. So what does temperature even depend on? For this part, I need a video. So what's happening inside an object? We've got atoms, and they're not just sitting there still. They're moving like this, okay? And the faster they're moving, the higher the temperature, okay? So this is a really high temperature, more motion, right? Or you can cool it down, and that's less. So we just said that the temperature depends on the motion, okay? And if you have more motion, then that means it's a higher temp, okay? It's a higher temperature. Let's introduce an important physics word, and that is the average kinetic energy of the molecules, okay? Kinetic energy is an energy of motion. We'll get back to that over and over in this course. But the temperature depends on the average kinetic energy of the molecules. And again, the more motion, right, the more kinetic energy, the higher the temperature. So the next topic I want to cover is heat. And heat and temperature in your normal everyday life, people use them sort of interchangeably, not really thinking. But in physics, we use our words very carefully. And so heat has a very specific meaning in physics, and it's not the same thing as temperature. So that is, heat is an energy, and it's the energy that's transferred from an object with a higher temperature to a lower temperature. So heat is not the same as temp. And it's really important, things don't contain heat. So you don't say that this mug of tea has a lot of heat in it, okay? Heat is, again, it's the energy transferred from an object with a higher temperature to a lower temperature. So let's take a look at this. Let's just say these are 2 objects. This is 10 degrees Celsius, and this is 40 degrees Celsius. So the higher temperature one, 40 degrees Celsius. Lower temperature, 10 degrees Celsius. You know it's temperature because that's the unit, okay? Now, what do I mean by heat? Heat is the energy that's transferred That's the heat, that there's energy that's transferred from this guy to this guy. In order for heat to flow, there has to be some thermal contact between these two things. Okay, so there has to be some way for the heat to flow, and we'll talk about the different ways that heat can flow next. But when will heat stop? Heat will stop flowing, so heat will flow until they reach the same temperature. Okay, at that point, heat doesn't flow, because what is heat? It's when it's an object with a higher temperature to a lower temperature. Well, if they're at the same temperature, then heat won't flow. Okay, and that is a very important point. That place that they have just reached is called thermal equilibrium.